Let's begin the section evading EDRs and AV. So, first of all, we have to learn about how this EDR or AV, the platform or this security tool working. So, I will go to Google and start my drawing. That will be helpful to figure it out. Uh, online TR whiteboard. So every EDR have a same working principle. Uh, it will do the same thing what malicious or malware executable will do. Let me tell with the background. If you take any operating system, there are two modes. One is user mode and one is kernel mode. Okay. So the user mode is like we are interacting with the application. So in the sense, the human interacting with the application that tends to the user mode. But in kernel mode, the application, this application will interact with the operating system drivers and etc. So there is a lot of procedures to do this kernel mode because user mode is easy. We can install the application and we can interact with the code, the programming code. So in kernel mode, we need a syscall to interact the kernel. So for example, take NTDLL. So this is the uh, Windows DLL. See, used to interact with kernel mode. So basically, we have many APIs more than let us take an example more than 30 APIs in NTDL module. So if you want to communicate with the kernel mode, you are using your application will use NTDLL, and NTDLL has set of APIs. These APIs make a syscall. So we called as a syscall. Syscall will make a interaction between the user mode, the application, as well as the kernel, the syscall. So we have a separate call for each API. For example, take create. Uh, sorry, this is called as NT because it starts with NTDLL. Create. Uh, there is a API called create thread of. So this API have a separate syscall number. So that is called a system service identifier or system call identifier. We can call it as anything, syscall or system service identifier or system identifier. So it have their own number. This API have their own syscall ID. We are using this syscall ID to interact with the kernel. So why we are using kernel? So we need the kernel for creating a new process. If there is any if there is any, if you want to create any new process, you need a kernel because kernel will allocate a memory, kernel will interact with the driver, operating system, everything. So if you want to communicate with the any sort of URL, then you need another type of API called internet open URL of. This will open the URL for the process. So you need a kernel for every set of things what you are doing in the applications. But we did not know when we installed the application, we do not know these other things are happened or not, but in background these all other things are happening. Okay, so now, so EDR. Okay, so you are installing your EDR sensor in the user mode. So take any endpoint detection and response or AV antivirus, take McAfee, Quick Heal or anything, Bitdefender or anything you want. So there is a communication between, there is one more thing, EDR driver, it will install in the kernel mode, driver. Okay. So let's take a simple example. So you are opening the notepad, okay? You are opening the notepad, and what you are doing in the notepad, you are writing some malicious base64 encoded PowerShell in the notepad. So when you return the notepad, basically our Sophos will get detect this notepad and it will delete the file. So how it was deleting? We just return in the notepad. How it was detected as a malware? How it's happened? So this is called as a hooking. So what they will do? There is a separate. Previously I mentioned there is a callback for every process. When you open a notepad.exe, this is a process creation event, right? You are double clicking on the notepad. Your PE, like portable executable loader, will go to your disk under the system32. So notepad.exe was present under the system32. So it will search for the notepad.exe and load it in the memory. Okay, so it will load it in the memory. So this is the memory. It will allocate a set of address for the program and pit what are the things they want. It will parse the export address table, import address table inside the notepad.exe and load all the DLLs. What are the APIs used? It loads all the things into the memory. Okay, this is the basic things. So now the EDR comes to plain it. Okay, so when you double click on the notepad.exe, I always mention there is some sort of API will communicate with the kernel mode. So what EDR will do? EDR will inject EDR or antivirus. Okay, it will inject their own code inside the notepad.exe. Okay, so how it's done? The technology they are using is called hooking, the API hooking. We are hooking something into the target process and we are monitoring, we are tracing that process, what the process is going to do. By this, we can completely know what the notepad.exe was executing, what DLL, what are the things were written in the notepad.exe. This is the way the EDR or antivirus softwares tracking your process. So in the depth analysis, when you are starting the notepad, there is a some sort of a API. Let I will give you an example. Create process of. Okay. So now let's say um, our Sophos. Okay. Example of a Sophos. Sophos injecting their APIs inside the into the create process API. Okay. So it was done by jump operator. Okay. So whenever the create process API was called, the EDR injecting their own code using the API hooking. So basically we can done with by jump operator, okay? JMP. I will show you in the practical way how it's happening. Uh, Let I will give some theory behind what happening here, okay? It will inject their own DLL inside the notepad.exe, okay? By using the jump operator. Whenever the create process called, it was redirecting to the jump operator, and this jump operator will call the EDR DLL and executing, sorry, injecting under the notepad.exe. This is the in-depth process what's happening with EDR and our applications. What's the depth, what's in depth, what's the background, what's happening. Okay, so let's say the program, let's say one more example. There is a program you are changing the program, what he will do, he will give conditional operator, right? You will do conditional operator if else, and you are changing your executable flow of the program. If it's equal to 0, go to this. If it's not equal to 0, uh, execute this. Okay, this is the thing, the same API hooking, the same process is called as API hooking. API hooking is also always called as, so we are changing the executable uh, executable code. Okay, like uh, so we are modifying the executable code in the another way. Okay, uh, so let me erase this first. um, so let's get into the depth for API hooking. So API hooking is called as, we are changing the executable execution flow of the program. uh, so now there is a 10 line of code. Okay, you are changing the executable flow of the program to stop this in between two lines. Your program will execute first two lines and directly come to the fifth line. So how it's happening, you are stopping this code, you are changing, you are doing some jump operation from this code, this line to this line. It will ignore this both line. Okay, this is called as a hooking method. So, hooking was introduced for purely a developing thing. So, I will give one more example. Let you want to modify the game. If you want to hack the game, like you are playing some shooting guns, your health was decreasing to 100 to 0. So you are hacking the game, your health should be stable in 100. You are doing some API hooking and changing the execution flow of the program. So there's some sort of API used for this thing, right? It's used for decreasing your health 100 to 0. So you are hooking that API, okay, changing the execution flow of the API. You are changing the execution flow of the API stable at 100. So it will change the execution code. It will change the entire process. Your health won't decrease, it will stay in 100. This is the another example of API hooking. API hooking was introduced for a developing thing. So previously, I will say one example. um, some other developer develops a code. Okay, and he written more than 10,000 lines of code, but he left the company. So now this 10,000 code, a new developer has been joined. He does not know about these 10,000 lines. Okay, but he knows what are the functions, what are the APIs they used. We can know all the things by using PE Studio. By using the PE Studio, we can know what are the APIs, what are the functions they are used. The new developer using these functions. Okay, he doesn't know the 1,000 lines of code, he don't know the 1,000 lines of code, but he knows the functions, what are the functions used in the programs. Okay, so he using this function and he changing the execution flow of the program. So now the code get modified, right? So this is called as a API hooking. So our antivirus or EDR is also using the same API hooking to inject their DLL. So who left? Okay, I'll have here. You are hearing my voice, right?
Yes, Ajay,
Yeah,
bro.
yeah. You are using this same API hooking techniques to inject the EDR DLL into the uh, remote process. Okay, basically, it is a kernel level operations, but the EDRs or AV, they will do it in a smart way. I will give the example. Let me go to my downloads. So you can see this. So I have my own antivirus, Quick Heal. Okay. Uh, when I purchased this antivirus, I trusted Quick Heal. Okay. So because you see the ratings and everything was good and it's a very costly antivirus compared to other vendors. Okay, I get it. I think it's 900 rupees for one user and one license. So it's getting entered. It's left for 21 days. Okay, so when I keep on researching with the red team and EDR evasions and antivirus evasion techniques, I come to know Quick Heal is the worst and worst antivirus in the market. I will give you the example. So I shared, where's the whiteboard? I said EDR or AVs will inject their own DLL in each and every process, right? So if there is 100 process, it will inject the 100 DLLs in the 100 process. So some of the EDRs or AVs will work more smart. It will target only parent process. So it will inject the DLL into the parent process and it will keep track every application what it was doing. Okay, so this is the way some of the antivirus will work. So that some of the antivirus vendors got a reviews like this antivirus was operating very slow. It will slow up the system because they are not working properly because they it was injecting every process. It was injecting their DLL. The DLL will consume high resource into the every process. The system RAM, everything was consumed. Memories, everything was consumed. That gives your system that slow down your system. So some of the EDRs will work light smart. It will target only the parent process. For example, explorer.exe trigger notepad now, uh, right? So so now the notepad is a child and explorer.exe is a parent. So it will inject their code in the directly in the notepad. Okay, but whenever the notepad.exe called some sort of malicious function, it have to inject their DLL into the function. Okay, so this is the way the antivirus have to behave smartly. Okay, so let me give you the direct example why I am saying my quick heal. It's a worst. So I said every process you having one of the DLL got injected, that is EDR or AV DLL. Let me search for a quick QUI. Okay, CK quick. So now you can come to know. So you can see that shell uh, experience host.exe have a DLL. Yeah. So let's leave. Yeah, Explorer 10242102408. Okay, let I will go to the this process. So you can come to know my quick heal injected some DLLs into my explorer.exe. You can see it here. rcscan.dll, registry.dll, gg something .dll, file.wrap.dll. Because my quick heal have a lot of functionality, protections, virus protection, scan settings, etc. etc. Okay, it has so many functionalities to prevent. So it obviously it will use many DLLs to prevent any malicious activity. But in my opinion, it have to inject their own DLL inside the Chrome also, because Chrome is one of the easiest target for any threat actor. They will they will directly go and inject the some sort of extension, malicious extensions, or they will load their JavaScript file, or they are download their own. third-party stager through the Chrome. So if they inject their own DLL in the Chrome.exe, that the things that malicious things will be get caught. But now they are not giving focus to the other process which can be targeted by the threat actor. Okay, this is the uh, thing every EDR or AV have to improve their detection functionality. They have to target the process which was easily misused misused by the threat actor. They have to inject their own DLL and monitor everything. Okay, so this is the one method of detection of how now I just clearly explained how these things, how these EDRs or AV are working in the uh, scanning every process or it's detecting process injection or anything. Okay, this is the way how the EDRs or AVs was working. Okay, so anyone have a doubt on this thing? How EDR or AV antivirus working?
So Ajay, like as you said, right? So whenever those maybe API or else .exe
Mhm.
doing some hooking, right?
Yep,
API hooking.
yep.
So for example, if we have one ADR, okay,
Mm,
example Sophos ADR.
mm,
So actually we have one host, so we have installed the Sophos is EDR agent on that host. Okay,
mm,
I'm trying to access some .exe file
mm.
on application. So automatically the EDR agent will inject some predefined code into the .exe.
Yes, it will
O-
inject
Okay,
because
inject.
it need to track everything.
Okay,
Yep, it need to track
okay.
everything. What are the, for example, the third party executable will dump the LSS. So that will be one of the malicious thing. It will access the LSS and it will dump the code and it will send it to the attacker as a C2IP. So we can't trust anything. If the reputation was good, EDR will allow that. EDR or AV that will allow to install inside the system. If it's get allowed, but we do not know that was a malicious, but threat actor know that threat actor created that exe and it was inside the memory, so it can easily dump the credentials or it can easily inject other sort of payloads into the computer and they can compromise the host, they can compromise active directory, whatever they want. So we have to monitor everything. What is the thing? What the processes are doing? Why notepad.exe accessing LSS? That was a malicious thing. Why notepad.exe dumped one of the file? That was a malicious. Notepad.exe dot not behave this. So this is the next generation antivirus, next generation EDRs.
Okay, so like from starting to till end of the process, the hooking will be
Yeah, hooking will be
stage
there.
the
Yep.
process, right?
Yep. When you close the process, the hooking will your memory will be get freed out. Now
Oh,
the hooking will gone.
okay, okay, got it. So while we are hooking the some code into the particular .exe, so the .exe is not maybe uh, misconfig something
No.
maybe misconfigured or else maybe the working is different or what?
No, it not misbehave, but there is some millisecond difference. It get loaded because EDR have to inject their own DLL. That DLL have to create a proxy between the target functions, and the target function have to give the code to the uh, next function. So there is a millisecond delay when you inject the DLL. That's why some of the antivirus will get fail in the review. Our system will slow. When I am starting process, my system it's hanged.
Yeah,
This is the
understood.
thing. Yep.
Yeah, got it.
Yeah.
Okay.
So
So every EDR and every follow the same mechanism, right,
yeah,
Ajay?
same mechanism. Nothing changed. Same mechanism they are following.
Okay.
So now let's come to the uh, topic. Let me clear your doubt. How it misbehaves. Okay. So let me focusing on API hooking first before unhooking. There is multiple type of API hooking. One is hooking with DTARs, the first method. We are doing the DTAR function because most of the things EDRs are using the DTARs. And second
Okay,
one is,
going further, I have a lot. Okay, so
yep,
the hooking, the API hooking will be applicable for all .exe or any other file extensions.
all .exes, whenever you're executing any MSI files, everything. If the process is created, it will inject their DLL.
Then it will be applicable for all, like
Yep,
kind of
yep.
PDF as well, because PDF also will execute some process, right?
Yes. So, for example, your PDF is calling some sort of API
Yeah,
that will
PDF
be
better.
flagged as that will be misused by threat actor. Your API, your EDR will inject their own DLL in that API also. It will target that API also.
Okay, got it.
Yeah. So DTARs, and second one is IAT, import address table hooking. And third one is inline patching. So we are not going to discuss about inline patching because this is a suspicious thing. Every uh, vendors they will block this, and this is the we are replacing we are replacing totally the code for the process, so it won't doing good. So we are discussing these two things, DTARs and IAT, not inline patching. Inline patching they are not using. So DTARs and IAT. Okay. Let I will first give. Yeah, Jerry bro is pinging. Let me reply with my. Right. Okay. Yeah, he is also joining. Let I will talk with the DTARs. Uh, this is the hooking method. One of the first hooking method that get introduced. So let's say your source code, okay, SC, have to access the target function. Okay. So before hooking, so your source code will be it's free to access the target function, and target function will uh, give the output to the source code. Okay, when you implement a call detach of function into your code, into the malicious code, what detach, okay, detach of function into the malicious code, okay, what your source code will do, the source code will go to the detach function, and the detach function, let I will add Jaibo. Hello Jerry bro, you missed many things.
Hi, hi.
Hi bro, you missed many things.
Yeah,
Blessings. And okay, let I continue. And this detach function will go to the trampoline function. Okay, so trampoline function, it will redirect to the target function tg, and this target function will send the output to the detach, and this detach will send out to the source code of the process. Okay, this is the way. So in between you have two possibilities. Okay, in between you have a interceptor called detach. You can inject your own code here. That code will get first executed here, and it will go to the trampoline function. Trampoline function will check all the things whether it was executed, and the source code API is called, and it will redirect to the target function, and target function will execute the target thing, and it will send the output to the source code, okay, the source process. So now our malicious code is also executing, and our target function is also called. So now the application won't crash. It keep on running. So this is the way the EDRs and AVs are using uh, using these techniques to inject their own DLL to the process. So next one is the IIT hooking. When you saw any of the executable, there is some header. Okay, so if you see a P header, so there is an uh, text function, text thing. So the text contains all the executable codes. Before the text thing, the meta information get stored in of the headers section and optional header. You can see it in the PBR. Let I will show that thing. Uh, PBR. So this thing will give good understanding. So how the executable will look. Windows x64. Jerry bro, you know right how the API, what is API hooking and how the antivirus AV it was working.
Yes, bro.
Yeah. I asked one question to everyone, but not
Okay.
for you.
Okay.
I will ask to you. Uh, let's say there's a threat, okay?
Okay.
There's a executable, malicious executable. It have to
Okay.
do a privilege escalation. What's the
Okay.
method it will be used to do a privilege escalation?
For doing privilege escalation. So it is a threat, right?
It's threat or anything. Threat, yep. Let's take a exe, okay? Let's take any exe that was a malicious exe that have to execute in the administrator mode.
Okay.
So because administrator have lots of privilege, we can easily lateral movement to AD or anything. So it have
Okay.
to execute in the administrative mode. So what that will do?
DLL.
And what's the method they are using?
Uh, yeah, like I don't know that exact name.
They will inject some code in the legitimate process. So
Yeah, that is
which
that
was
is why
running the
DLL, right?
not DLL.
Or registry.
No, bro. I will give you the exact thing. I'm searching one thing. Windows System 32. Yes. System.
So similar to thick line pen testing, like DLL injection is there, right?
We can inject a DLL
Yeah.
and we can inject
So by the
some
same
amount
way,
of
this
code.
can also work, right?
Yes, same amount of code
Yeah.
they will inject. And notepad.
Actually, today I went to office too.
Oh, is it? Why,
Yeah,
bro?
I was not in shift now, bro. Today I went to set up that machine.
Okay, okay. Yeah,
Yeah, got
okay.
the hardware locker and just kept the system there and logged it.
Okay.
Informed Balaji too. So waiting for that network connection. Network connection, we had some conflicts. So
Okay.
after Balaji is there on Monday, we have to work with him and try to get. Else we'll start up with black box testing first.
Okay.
Yes, they will use some of the methods like one is process injection. They will inject a DLL or a malicious shellcode in any other process which are running on the administrative permission, or else
Yeah.
they will go for
So then, Ajay, I'm
UAC
right,
bypass.
right? I'm right.
Yes. DLL injection. DLL injection
Yeah, yeah,
is also work. That is same type of process injection.
yeah,
And
yeah,
another one method they are using the UAC, user access control bypass. So,
yeah,
for
yeah,
example,
yeah.
let's take the user have local admin privilege, but he is
Okay.
in, for example, I will go to the command cmd and I am using who am I slash priv. I have this sort of privilege, so I do not have any local admin privilege or any high privilege to do this. When I am using command prompt with run as an administrator, it's showing on window use UAC. It's called a user access control. So Ajay, this user is Ajay. I have an administrator access. I have a local admin access, but previous window it not a admin access. It will we have to run the command prompt in the administrative mode. It are asking UAC. So when I'm running this who am I slash priv. So this is one of the command we are seeing in most of the active threads um, to elevate privilege. Okay, so now I have this much of privilege to do anything in the system. So this is the thing they will try to bypass. We can use two modules in Mimikatz called run as admin and elevate. These are the two modules we can elevate UAC using Mimikatz. Okay. And
Hmm.
and one more thing, they will go for any unquoted service path vulnerability. So, for example, when you are taking any services which you are running, I don't know. Yeah, I will give you example. Any service which was running without any codes, there is a space in between the directory. The space should be covered with double quotes. But if there is no double quotes in the space. Service, so they will directly inject their code in that function in that service, and they will execute. That will also go to the privilege mode. And also they will look for any sort of vulnerability in the kernel or any sort of vulnerability in the applications which was executing uh, in the kernel or in the OS. They will use that vulnerability to elevate the privilege. Mostly they will go for this thing, process injection, because that was a simple way they will access privilege. So I previously said in where is my whiteboard? In the any executable, there is a uh, set of headers called entity headers, file header, optional header, and this text section contains all the executable code. In our case, if it's a malware, our this text section contains the malicious code, and you have a resource data, R data. R data contains all the images, icon, everything, and relocate. We are not focusing these things, okay? And our uh, headers containing the let me go to the section header. Okay, so okay, so now you can see what are the things how to import. There is a kernel 32 DLL how to import, and the GDI DLL was there, user 32 DLL. These are the importable functions for the notepad.exe. And what is for the there is one more thing, export. Uh, there is two types of things. One is the import address table and one is the export address table. They both are present under every application. So this import address table and export address table contains all the DLLs, which are the DLLs we are using inside the DLL, which are the APIs we are using. I showed in the PBR. Import address table, you have these are the APIs you are using when you are running the notepad.exe. And there is one more column, export address table, and that export address table have some sort of DLL and some APIs. What are the things to work? You can see here, get proc, set windows placement, and get system menu, and these APIs inside the user 32. This will be import as a one executable, and you are executing that. Uh, in the operating system. So basically, that executable contain a lot of things, lot of informations. When you are doing malware analysis, you can come to know this. PBR will do this type of splitting, and it will show all the data. So what are the things we are using? Okay, so yep. In the import address table, I already said there is lot of APIs and DLLs which are using uh, for the process to do certain type of activities. In the import address table, what you are doing, you are injecting your own call, okay, your own API. For example, your own API, it's like you are calling, let I will say this is the correct library they used for call load library uh, a of function for calling any type of DLLs. Okay, you are using load library function and you are directly injecting the EDR or AV DLL inside your process. So we are not our EDRs or AV not using this type of uh, this technology because this technology is mostly used by the threat actors. Um, to inject to hook any of the application uh, or executables. Okay, so mostly we are focusing on detars. This is the only method that our EDR and heavy get focusing to inject their code inside the process. Okay, so by this way our process or your executable get monitored by API hooking. Okay, let we will discuss the next thing.
So Ajay, is there any difference between dators versus IIT?
Yep, detours you are, let's see, 1 second, bro. Yes, detours you are calling the detach function. You are using one of the function called detach and implementing some sort of things. Our executable have to uh, when the source code call the DLL, our that call will go to the detach function, this function, and detach function will redirect the call to the tamperine function because detach will execute all the malicious, all the things. What are the things we have to inject? What are the what EDR have to inject? And these detach after completing the injection, this detach will redirect to the tamperine function, and the tamperine function will see everything the connection between the proxies and these source code API calls and this DLL got injected everything. It will check everything and finally it will redirect to the target function. So they are using certain type of API in between these these things and redirecting, jumping to one API to another, and finally the target function. And this target function will give the output to the detars, and these detars will go to the source code, the output to the source code. But when you are doing IAT hacking, sorry, IAT hooking, import address table hooking, you are injecting your own, sorry, the load library of, okay, you are calling your EDR DLL in this thing, okay, in the header. So whenever your application will get executed, okay, it will get called or it will uh, basically we are injecting into the import address table and we are using one sort of API called create remote thread of. This will create a remote thread into the function what you are hooked into inside the import address table, and it will create one sort of thread and execute the call. So we are not using details of function. We are directly going to the import address table. We are parsing. Okay. Basically, we can say it as we are parsing the executable and going inside the executable uh, inside the IAT. Okay, IAT section, import address table section. Basically, this thing. Okay, imports. We are directly going inside this, and we are injecting our DLL inside this, and we are creating one new thread by calling create remote thread of function. Okay, and this remote thread of function will execute this API. Okay, this call or DLL what we hooked inside the import address table, it will call the DLL what we hooked in import address table and it will execute that. So this is the difference. So threat actor will go this technique But our EDR or ABs, they will mainly focusing on this sort of functions. Let I will, yep, this is the thing. Did you got it, bro?
Yeah, bro. So, like currently, our EDR and AV technologies are using the data
Datas, yep,
track. Yeah.
yeah,
Not
DTOS,
for not for IIT, right?
yeah, not IAT. They are going with detach data functions to implement their DLL. Okay,
Okay.
so uh, let's say. So now we learned about what is hooking. We are in hooking. We are changing the executable execution flow of the API to load some malicious code or some sort of DLL into the process, and we are monitoring the process. This is called a hooking. Now we can go to the API unhooking. Why we have to unhook? Any answer?
Yeah, like once we have completed the process completion, so if still the hooking is applicable to the particular file, so maybe it will run some. It will take some maybe some RAM.
Not that answer, bro.
Okay.
So whenever your executable stop its execution or it will terminate the process, your memory get freed up. Your memory buffer will be empty, right? So your API hooking will also get freed up. It will also removed from the memory. So nothing there. No need to monitor whenever you terminate the process. So threat actor can't able to do anything because the application or the particular exe was closed. So in API unhooking, before I mentioned we are monitoring our DLL, sorry, our EDR monitoring using the technology called hooking, right? Our EDR or AV using the technology called hooking to monitor the process, right? So what if you unhook this DLL from the process? What happens? Did you get an idea, bro?
No, bro.
No. Yep. So basically, we are using hooking, right? So let's say you are using hooking to monitor the notepad.exe, right?
Durga bro, Durga bro.
Yeah, bro.
So you are not getting this point.
No, bro.
So basically nothing, bro. Like, see, our monitoring, our managed systems were installed with an on like agent, right? Qualys
Correct.
agent or maybe some
Yeah.
other
Yeah.
EDR agent, right?
Yeah.
So that will be hooked via one API call. So in
Okay.
that system, if any issues or some wrong process or clone of some any legit EXE is running, it is immediately alerting us, right?
Yes.
So just to disconnect that, we are unhooking. That's it.
Okay.
Yep.
So
So
similar process. Bit
practical
changes will be
way.
there, but similar process.
So let's see. We are so let's take Explorer and I'm going to the quick heal. Okay. I am unhooking this DLL from the explorer.exe. What happens? The antivirus won't monitor explorer.exe, right? Because there is no DLL inside the explorer.exe. By using this DLL, it was monitoring the process. Now you got it, bro?
Yeah. Yeah.
Yeah. This thing we are using in EDR evasions, EDR or AV or anything, okay? This is the method we are using to evade EDR or antivirus programs. So this technique will use all type of EDRs, all type of antivirus programs. Uh, Currently, there is a cybersecurity market. We can say hackers are saying Sentinel-1 was performing good comparing to other EDRs, But if you are using API unhooking in Sentinel-1, that will also work. So our EDR will get failed if the threat actor know how to unhook the DLL from the process. Okay, so the code is like that. The path is like this. You are doing some sort of process injection, okay, in certain application. For process injection, you have to unhook the DLL from the target process. For example, you are injecting the some shell code into the Chrome, okay, Chrome, and this method is called a process injection, obviously, because we are injecting some shellcode into the Chrome. Okay, so what you are doing, you are unhooking the EDR DLL from the chrome.exe. So now our chrome.exe won't get monitored by EDR or AV. Okay, now you can hook the EDR, sorry, hook the sorry. Now you can hook the code, hook the shell code into the chrome.exe. Your EDR won't monitor. EDR won't consider what happened because it was not it was not monitoring. It won't create any alert, no alerts. There is no detection because it was not monitoring in the Chrome. So our Chrome get hooked and injected. Shellcode was injected inside the Chrome. So EDR, DLL get unhooked. Nothing. So our EDR will get fail. EDR or AV will fail in this thing. But they are using some sort of detection mechanism to do uh, best uh, in this detection. So they are tracking some sort of APIs. If this API used to unhook the antivirus DLL, it have to stop. Okay, so let's I give uh, with a good example. Okay, so let's consider. Okay, I will say there is one executable called mal.exe. Okay, so this mal.exe was a legitimate application. Okay, so there is no malicious reputations, and the hash is also not blocked. And you are installing this installed. Okay, you are installing this mal.exe in the Windows. So now the mal.exe was performing some sort of malicious thing. Basically, it was dumping. It was accessing elsas.exe. Okay, so now you by seeing this we can know if the third party softwares or third party application, it was accessing elsas.exe. That was a malicious thing. That was not a good thing, because this is a third thing, third party accessing elsas, and it will dump the SAM, and it will do certain type of attacks. If we can use for recon, or we can use for uh, evade everything. We can go to the if you know the administrative part, we can evade everything. We can go to the AD, and we can compromise everything, right? Now our EDR injecting their own DLL in the mal.exe and monitoring the process. Now when you call the elsas.exe, the elsas.exe will get detected. So it will stop and terminate the mal.exe process. So the process will get terminated. So this is how your EDR detection and response it was performing. So basically it will stop the process, but most of the EDRs won't do. It will detect the process, not stop. Okay, so I will give many example EDRs. McAfee, you can take the McAfee. It will detect, but it won't stop that. It will detect. Okay, it will create one alert, or mal.exe was dumping elsas. It will create an alert, but it won't stop the particular attack. So they have to improve their mechanism. Not only McAfee, many vendors are doing this in AV also, like Bitdefender, Quick Heal, or Kaspersky. They are all are doing. They just detecting that they are not stopping that attack. Okay. So now in API unhooking, I said the mal.exe was hooked. So how we can perform our dump? We have a we need to perform a LSS dump. LSAS, yes, LSS dump. This is our target. We have to perform. So what can we do? So there's multiple methods for API unhooking. So there's a classic way for API unhooking, but that will get detected by antivirus or EDR program, not antivirus, EDR programs. That was a next generation AVs, EDRs. Um, and there is Hell's Gate and Hook's Gate. Sorry, Hallows Gate. So Hallows Gate will work most of the time. It will very good technique to unhook the EDR DLL from the process because there is no complicated DLLs, complicated APIs will get loaded. So our EDRs or our AVs don't know what's happening inside this thing. I will explain the technique afterwards once I will go through the classic way. And another one is parent sort. PERUNS parent sort. Okay, there is that method also. We have some sort of methods, and we have mm, one more thing, event tracing, disabling the event tracing, so it won't get logged into the EVT. So our EDR will fail to investigate the when EDR will investigate the EVT events, and module stomping, but it will detect that was not a correct way to implement API hooking, but it will work. Not all AV, it will won't evade all the antivirus and EDRs because they are openly using some sort of malicious function that will get detected. I will talk that thing in I will talk that thing briefly. Okay, so now your target is LSAS, so you have to dump the LSAS.exe. And for dumping the LSAS.exe, there is only one thing: you have to unhook the DLL, or you have to uninstall the agent, that EDR agent from the machines. That won't work because the administrator have to do that. Yes, the administrator only have the access to do that thing. Okay, so if the local user, sometime if the local user are doing uninstallations, the most of the EDRs are not allowing the local users to uninstall the EDR agent from the machines. So that will also fail. Um, that techniques won't work. So the only technique we can use the unhook the DLL from the mal.exe. Okay, so I will draw this. So we have EDR DL from here. Okay, yes, done. Let's say how, first of all, unhooking the DLL, you have to know which address, okay, which system call or which memory address the EDR.dll was present in the machine. What is the base address of the DLL? So previously I mentioned basically when the NT module or DL this thing get loaded, there is some sort of API will called. The EDR vendors target that APIs and injecting their code because every process will access NTDLL to accessing kernel, right? So if you seeing every process, if you are seeing browser, if you are seeing Explorer or Notepad, every process have their own NTDLL to interact between kernel mode. So they are using NTDLL, they are using kernel 32DLL, and they are using kernel based DLL. This type of ELL, sorry, DLL, they can used for hooking. Okay, so inside the NTDLL, you have seen multiple APIs. I will uh, explain it in practical way that how it's happening. Where is the? I need x64. Yep. Let me go to the release x64. You have. I think some of them have some experience in in this thing. Uh, x64. Let I will open the notepad.exe. Yeah. So this is one of the malicious PowerShell code. Okay. So I will open notepad.exe. That will work. Now notepad.exe was opened. I will attach this notepad.exe in the x64 debug. Let I will attach. Yes. So when I'll go to the symbol, so you can see what are the DLLs get loaded. So when I am selecting NT in the right hand side, you can see every API calls. Okay, you can see NT query, NT, what are the API calls used from the NTDLL process. Okay, so if you see it have their own address. So let's go to the NT create. Um, uh, okay, let's take create remote create threat CREATTH. Oh, yeah. So this is one of the API most of the EDRs and antivirus vendors are targeting to injecting their own DLL into the process. Okay, so let I will go to the uh, ND create thread AEX function. Okay, by double clicking this, you can go to the same function. You can see the same address 25400 here, and it's pointing towards move R10 RCX to R10, and you have the syscall. Okay, this is the syscall ID C5. Okay, to call the EZW create thread ex of function. So after that, you can directly go to the syscall, right? So I already mentioned syscall is the thing we are using to interact. The application will use the syscall to interact with the kernel mode, right? So you can see after the C5. So this is the syscall number C5, and syscall C5 will get loaded in the EX registers, and this register will call the syscall. Okay, this syscall will get called, and if it will call the EZW create thread ex function. Okay, right. So my antivirus software, Quick Heal, not care about anything. Okay, it's not caring about anything because I shown it only targeting this explorer.exe. It's not targeting any notepad or nothing. It's not targeting notepad. So it's not injecting the DLL or the code inside the notepad.exe. So we are not seeing in the x64 debug, it's not injecting any other code. Okay, so if, for example, if it was injecting their own injecting or hooking the DLL in, inside the ECW create thread function. So you can see the jump instead of move. Okay, here you can see the jump function. So this jump function will redirect to the, okay, this jump function will redirect to that DLL, that antivirus or EDR injector DLL, and it will execute that code. So how to find out that? Okay, I will give the example. So you can see every process. Let's take create remote thread of, it's starting with 4c, right? 4c, and create thread stage time of, it's starting with 4c, but now but the syscall identifier was different. Okay, and nt create timer was starting with the 4c, and nt create timer 2 was starting with the 4c. So if you are um, seeing any DLLs, EDR injected x64, let's say EDR hooked uh, DLL x64. Let I will see the image. Yes, let I will load this image in the new tab. Yeah. So you can see there's a jump statement, right? It's starting with E9. It was hooked, right? It's starting with E9, and you can see the jump statement, jump condition instead of move condition. But here you can see there is a move condition in every API calls. In every API calls, you are here. After the move condition, the syscall number C5 will be called, and the C5 will be stored in the EAX register, and this EAX register will call the syscall, and it will directly go to the create SW create thread of functions. So this is the basic thing. But when you see this image, uh, so there's a jump function inside the allocated visual memory of, and this jump function will it's redirecting to some sort of address. That address contains that antivirus DLL. So it will go get load. This is called a hooking. This is the way how the antivirus or EDR will hook inside the process. So when you are seeing anything with E9 and jump statement, okay, jump condition, you can come to know there is a hooking. So we have to unhook this. So how can we do that? Let me go to my mail.exe. I already said there is a address. Okay, let's say this is the address that can be hooked. Okay, go to expression and uh, if you follow it copy address. Let I will go to the function. Go to um, okay, we are in the same API. Let I will okay. When you are going to the function, okay, when you call this address like 25400 25400, for example, if the EDR hooked the DLL in this address, okay, in this 25400 address, you have to unhook the EDR DLL by calling this address, okay. So let I will explain in brief. There is a address, okay, which get hooked by EDR. So we need to overwrite that address, okay, with our original API code, okay, original API. So if you are overwriting the address for calling the original API called, for take example, set w create remote thread of, it will unhook the uh, DLL from the DLL from the process, right? So this is the method we are using. So we have some task to do this. So you need first of all you need which DLL get injected. For example, uh, is that create thread ex functions was related to the ntdll. So we can come to know ntdll dot dll was injected. Okay, right? So ntdll dot dll was injected. Let I will write that right here. So in our scenario, ntdll dot dll got get injected, right? So we need a base address for an ntdll module. Okay, if you find out the base address, so we can find base address by using get proc address of API. There is one API function used to getting all the address. We can call get proc address of the get proc address will return the output of base address. Once you find out the base address for ntdll, so you have to go to the ntdll module and find out which uh, API function get hooked. In our scenario, let's take we are taking create remote thread of this API get hooked. Okay, let's assume this API get hooked. We have to go inside the NTDLL headers and find out which where is the syscall ID. Okay, so the header information contains all the syscall IDs. Basically, it contains the RVA. We can say it as RVA. Let I will show in the process view. RVA, sorry, PBR. Uh, yes, this is the RVA. Okay, this is the RVA of the functions. When any API gets called, let's yeah, create smart core.exe. There is a original chunk, original chunk, and the original chunk will redirect to the RVA. So basically, that was a some complicated process. It have to find the RVA is called as a relative virtual address. Okay, so we have to find out the relative virtual address of the function by using the original chunk, this thing, this address. Okay, so we can use some sort of functions to do this thing. Once you find out the ZW create remote thread of create thread RVA relative virtual address, you can call the first 5 bytes. Okay, you can remove the first 5 bytes. So this is the 5 bytes. You can remove the first 5 bytes function. Okay, first 5 byte address of the API get hooked. Okay, this address, and you can replace the RVA address here. Okay, relative first 5 bytes of virtual address here. So now our API, which was hooked by the EDR, will get suspended, and our new ZW create remote thread function will be get loaded in the address. Okay, now the mal.exe will call the elses.exe without any sort of monitoring by EDR. Okay, it will call the elses.exe, and it will dump the SAM, security account manager. So this is the method. This is a classic method. This is called as the classic API unhooking. This is the method they are using to unhook the API from the process. Okay, but there is some sort of suspicious thing happening here. Our EDR will detect catch it easily, but not all EDR, but some EDR will easily catch up it. We are using get proc address of, right? The EDR will inject their own DLL inside the get proc address of, and now we will monitor what get proc address will we do. It will take the base address of the NTDLL, and it will search for the uh, and it will go inside the NTDL function, and it will search everything, and it will search the relative virtual address of the ZW create of, and it will load the process. No, now we got caught in this thing, right? So some EDRs will do that. Some EDRs, in the sense, some strong detecting EDRs will do that. Not all EDRs will work in this. It will bypass many EDRs, but some EDRs it won't. Okay. So now we need another method. Okay, this is one method. Any doubt in this method?
No, bro. So classic, actually they will change it the what is RVA address, right, inside
Yeah.
the hook. Okay, the hook to
So
HANA.
now our hook get suspended.
Yeah.
Our new NTDLL ZWS create API will get loaded into the process. So now our process will work fine, and it won't crash, and we can do all the malicious activity.
Okay. So while we are unhooking, why this maybe EDR will alert to us. This is kind of very like
No, you won't get an alert. If
like
sometime if your EDR inject their own DLL inside the get proc address of API, you will get an alert. Apart from that, nothing. So you won't get any alert. Whenever there is a C2 connections, nothing. You won't get alert. If the C2 connections reputation was bad and it was blocked by the firewall, then you get alert.
No, bro. Like while we're unhooking, right, with help
Yep.
of the RV address,
Mhm.
maybe is there an alert mechanism?
No.
No. Okay. This is one of the drawback, right, from media side.
Yes.
Okay.
Yep. And the next method, they will use Hell's Gate. So name itself, it's very strong. Hell's Gate. It's a very, very complicated method. Um, the Hell's Gate, the working principles of the Hell's Gate. Because the same method what we are used in the classic DLL injection, our mal.exe have to unhook the DLL, but here we are using instead of get proc address, okay, instead of using get proc address function, we are implementing many methods, like we are going to the PEB. We will say it as a process environment block. So for example, whenever the process get loaded from the whenever the P loader get executed the process, any of the process, your process will get loaded in the memory. So same time, the PEBE, the process environment block will create. Okay, it will keep track every instructions, what are the things happened in the process, what are the APIs get called, what are the address value of the APIs. It will keep track everything, process environment block. Okay, so there is one more thing, TEB, that is called as the thread environment block. So if you are not using the get proc address module here, okay, if you are not using get proc address, you have to rely on this technique, PEB. You have to go to the process environment block and you have to find out the NTDLL base address first. Okay, so first thing, you have to retrieve NTDLL base address using PEB, process environment block. So this PEB contains every information, what are the base address, what are the API address, what is get loaded, virtual address, everything. It contains every information. And second thing, once you find out the base address of the NTDLL, so the next thing, we know the base address of the NTDLL, you have to search your base address. So we know the base address of NTDLL and it was a NTDLL function, and we get into the NTDLL module and you call the syscall for ZW create remote, sorry, create thread of. Okay, okay, this is the very complicated method because we are implementing many things. We are getting into the NTDLL base address using PEB. This was a big programming process. And next thing, after you getting the base address of the NTDLL, you have to go next. You have to search for the uh, functions inside the NTDLL. SW create a remote thread of functions, and you have to take the uh, uh, syscall identifier, syscall of the ZW create a remote thread of, and you have to call the syscall directly. Okay, this is also this Hell's Gate is also called as the how to okay, this Hell's Gate is also called as the API hooking, and it's a method called we are directly calling this is called here, right? We are taking the ZW create remote thread of function thread of syscall, okay, and we are directly calling the syscall without loading anything, right? Uh, so how we are doing this? Should I implement it? Syscall. Okay. Let I will. there is something to methods. I can. So how we can call our syscall directly? Let I will explain how the syscalls will get work. First of all, when you are calling, create remote thread of function. Okay. So let's take. I will explain how the syscall will get executed. Okay. When you are calling, create a remote thread of function from the user32 DLL, for example. Okay. So this will go to the next DLL, create remote thread of and some sort of DLL called okay. Let's take ADV add webp. Okay. So I have not written EZW. So EZW. Uh, so let I will give. So you can see it here EZW NT. So this the kernel module. Okay. So this is the APIs used to interact with the kernel, ZW, NT. If you can see, just create timer, sorry, create thread ex of, that was not a kernel module. That is just a call. That is just an API call. That's not a syscall. That is just a API call. Okay. So how it happening? Uh, yeah. So next it will go to the some sort of APIs, okay, like add web EDL, and add web EDL give the interaction to NTDLL, and NTDLL will load the ZW create thread of, and this is the user mode, okay, this is the user mode, and now NTDLL have access to the kernel mode. So this is what's happening when you are calling any sort of API. Your API will get redirected to user 32 or any other DLLs. Then finally it come to the NTDLL. Okay. So that's why we have import and export address table. Okay. So it will get confused because if you are learning depth in malware analysis, you can get understand because it was full of related visual address and base address. It was full of dealing with the address sort of things. It will get confused. Okay.
You're
I will
correct.
explain it.
You are correct.
Yep.
The first method I can understand, the classic one, but this one bit complicated
Yeah,
method.
it was a complicated. We are going depth in kernel.
Yeah.
Yep.
JD bro, are you there?
Yeah, bro.
He sent message. Oh, morning shift. Oh, okay.
Yep.
Maybe we can finish it.
Yeah, he was going in a good flow, so I was like not to disturb.
Oh,
We are interacting with the kernel by using NTDLL finally. Okay. So in our health and hallows method, we are directly calling the ZW create remote thread of without going with these functions. Okay, we are directly taking the ZW create remote set of address, and we are directly calling these functions. So now our API, now if you have a syscall, direct syscall for the ZW remote thread of function, okay, let's take thread of function, so you can call directly, like now your ZW remote thread will be loaded, and you are calling this in the syscall. In previous method, we go to the process called get proc address. We first get this proc address and we load it uh, uh, into our this thing, right? Into our move r10 rcx in this thing, right? In the classic method. But in this method, we are not using get proc address. We do not need this proc address, exactly this one. We are directly going to the ZW remote create remote thread of using some sort of method called pub. Okay, process environment block. I already mentioned whenever the process get loaded into the memory, process environment block track all the APIs and all the base address, everything. used for the function. So we are going to this process environment block, and we are copying everything what we need, and we when we got the create remote thread of syscall, and uh, we are replacing our code. We are replacing our code in this. So now our it went okay. Our process won't redirect to many things. So our we can skip this both things. Okay. Also, we are not using get proc address of this function. So our EDR will get evaded. So EDR won't know what's happening in the system. We are directly calling the syscall, right? So we can when we directly calling the syscall, we will unhook the DLL in the process, and uh, we can load our new setup remote set of functions into the process. So it will execute our code. So this is the another way. But this is a very complicated way, and it was also detected by AVs. I will share how it will get caught by AV. Uh, so yeah. So whenever you use syscall directly, okay, uh, by calling any sort of DLL, that was a malicious behavior, because normal application won't do this things to load a API call, like interact with the kernel. Normal application won't do this activities like calling the direct syscall. You won't see it in these. You won't see it in this method. It won't calls it directly. It will load some sort of create remote thread of memory inside the memory, and it will call the syscall identifier, and syscall identifier will go to some sort of things, and it will call the syscall using the NTL. Nothing there. Okay, so nothing going depth. Okay, but in this method, you are directly calling the syscall. It will reject this three function. So you are not using these three things. In the syscall, you are using the address, and you are calling the API. So there is only one thing. So you are replacing these three codes, these four lines. So it will get hooked. It will get caught, not hooked, get caught, because you are using syscall directly. Most of the EDRs will uh, detect the application which are using syscall directly as a malware. So malicious application will do this type of activities directly calling the syscall without calling the user 32 DLL, or for example, create remote thread of this API. It's directly calling the ZW. It's a API. It's a kernel interaction API. When you calling the functions, it's related to the kernel 32. Sorry, it's related to the kernel interaction APIs. So it will be in the DLL 32. So you are directly calling this. It will get caught by most of the API, not all, but most of the things which have the better better detection rules. Okay. Um, this method will also fail when you uh, trying to execute process injection in the remote process. Okay, then we have a very powerful method called as Hallows Gate. I like this method because of it will bypass everything. It won't get caught. Even it won't get caught in Sentinel. I see a recent post from the security conference, one of the conference. Um, they are using this Hallows method to bypass, to unhook the Sentinel-1 DLL, Sentinel-1 Microsoft Defender, and AMSI DLL completely from the process. So it bypass three top vendors, top EDRs uh, in the market. Okay, this is called Hallows Gate. So I will explain this method in a practical way. Okay, so when you have so see this function setw create remote thread of. When you go to the next function, okay, so when you take this thing from this is a 32 bit. Okay, so this paste. to the space between the first call ZW create remote create thread of to the next call was a 32 byte. Okay, in 64-bit architecture machine, that was a 32 bit. Okay, 30, sorry, 32 byte. Okay, that was a 32 byte. The space between the first call and the second call. Okay, so if you are taking the 32-bit architecture, that was a 16 bytes. So that will be a 16 byte. Okay, so why I am saying this, um, let say our ZW create thread of function get hooked by EDR. Like here you can see the jump operator, and here you can see E9 starting with E9. So we can consume that. We can assume that ZW create a thread of functions get hooked. So the space between the first call and the neighbor call, the second call will be 32 bits. What you are doing, you are jumping next to the neighbor call. If the this function get hooked by the okay EDR, you are jumping to the neighbors up or down. You have to select either up or down. So you can program like this. Okay, if the function starting with E9, go to the next, transfer the call to the next 32 bytes. Move 32 bytes and go down. Then you can get the NT create thread state change of API. Okay, so sometime this API also get hooked by the EDR function. Okay, so next you have to go up. Okay, 32 byte, 32 byte, because it was a 32 byte, the space between here and here, first call and the second call was a 32 byte, and you have to go up or down neighbor call to the 32 byte. When you are finding the function which were not hooked by any of the EDR, so like 4C, when you are finding the function like 4C, you can program like this. Okay, when the function start with 4C8BD1, you can use the if operator, if or if else operator to do this, because they are I can read most of the codes when I am researching about these topics. They are using if conditions to do this activity. Okay, they are moving 32 bits up or down to the one call to another call, and they are searching for this function. If it start with the 4C, then they are assumed this API call that was not hooked. Okay, if it start with the E9, that API call was hooked, because we know from, I showed that image, we know from that image the process which was start. Okay, the address which was start with E9, that function was hooked. Okay, we are keep tracking this. Whenever we found the function which was not hooked by EDR or AV, we are going inside the function and we are calling the previous one. So how we are calling? Okay, so I discussed previous. Yeah. So our hooks gate have one of the disadvantage. We have to go to the PEB and we have to search for the NTDLL base address. After searching the NTDLL base address, you have to go to the ZW create remote thread of syscall, and this was a big process. We are using the big process, and we are calling the syscall directly, right? In Hallows Gate, yeah, in Hallows Gate, you are not calling the syscall directly from the directly. Okay, you are inside the NTDLL and calling the syscall. That that is not a direct calling. You are inside the NTDLL because you are in the neighbor function. Okay, let us say NT create timer of function that was not hooked by the EDR. So NT create timer was later to the NTDLL. We are under the NTDLL and we are calling the function, and we are calling the previous function called create thread of. Inside this, when we are inside the create timer, and we are calling the function called ZW create thread x of. Okay, so this is not a direct calling. This is the call from NTDL. We are already in the NTDL. We are inside the NTDL because we are inside the NT create timer, right? Create timer function. Okay, so we are moved one, let's say this function get hooked, this function get hooked, and this function is not hooked. We moved 32 bytes, 32 bytes, we moved totally 64 bytes. We are, the Halos gate have one more advantage. It will uh, dynamically solve the syscall functions. Okay, it will it will solve the syscall identifier dynamically. Dynamically. Okay, this is one of the advantage in Halos Gate, and it makes simple to inject uh, to successful injection process injection, and it will successful in API hooking and unhooking, sorry, unhooking. Okay, because the method was simple, it will also solve the syscall address dynamically, and it is not a direct call by using syscall. We are inside the NTDL module, and we are calling the inside the NTDL, and we are calling the syscall. That was not a direct. Okay, yeah, this function. Okay, let I will give simple representation. Let we are in the NTDLL already, because we are in the neighboring functions. Now we are inside the NTDLL, right? And we are using the syscall to call the DLL. So now the kernel will get interacted, right? So this is the way. In previous method, in the else gate, you are calling the syscall directly to interact the kernel, so it get caught by the AV, right? So now in this method you are not uh, you are not calling directly, you are inside the NTDLL. That's a neighboring function, and calling this is called uh, it will interact with the kernel and solve the API what you need. Okay, so this is the thing. Calling the calling the function directly and indirectly. This will work in all the EDRs. It will bypass every EDRs and AV. When you are doing any sort of process injections, it will definitely work. It will definitely work in every EDR. Okay, it will definitely bypass everything. So there is no detection rules for this. They can't able to write any detection rules. If they are writing any detection rules for this techniques, the most of the application will get failed to execute. Okay, that's the problem. So Halos Gate solving the, okay, we discussed these things, and it was solving the address dynamically. How it was solving the address dynamically? So I said we are moving 64 bytes from the original syscall. What we are doing, we are inside the NT create timer off, and we are calling the we are solving the syscall dynamically using the 64 bytes. We are moved 64 bytes. How it was. Uh, See here, create thread ex functions was in the C5, right? In the C5 register. Okay. The syscall identifier was C5, and it was in the EX register. And when I am moving to the next call, you can see C6. It is a linear number, C5, C6, C7, C8, C9. So you can solve the syscall identifier very easily. It is a linear mechanism, right? If you are going up like C5, C4, so you can increase one step, increase one, C4 plus 1, C5. You can increase one, C4, C5 plus 1, C6. That will solve the API calls dynamically. When you successfully solved the API calls dynamically, and now you have the syscall ID for the functions. That was a C6. Okay, so we moved 64 byte, 32 and 32 64. We are using this thing to solve your syscall dynamically, and we know we are in the C8. Okay, we moved two times, so we reducing C7, C6, and finally we are in the C5. Then this, okay, we are here. Okay, C7, yep. C5, C6, C5, C7 minus 7 minus 2, 5. We are solving by this thing dynamically. Okay, using create ZW create thread ex of. So now you have the syscall ID, and you are calling the syscall indirectly. So it will bypass every EDRs. Okay, this is the method. This is the method they used for unhooking the DLL. They are jumping. Basically, this is like they are jumping to, if the API was hooked, original API was hooked, they are jumping to the other API, to the neighbors which were not hooked, and they are not hooked, and they are injecting. Sorry, they are inside the. API called ZW create timer, and they are calling the previous API. They are solving the syscall dynamically. Okay, I'm get confused. Getting many address these things in my mind. This is a very complicated concept to explain this thing. I take many
Ajay,
more time to investigate.
yeah, Ajay, you guys continue. I'll just go for bed.
Yep,
Else I can't wake up tomorrow.
yep, bro.
Yeah. So bye Durga. Tomorrow I'll connect.
Yeah,
Yeah.
sure.
Bye Ajay.
Bye, bro.
Good night. Thank you.
So this is called the hello skate. Okay. Uh, Now who all are in the call? Okay, you and me. So this is the method they are using for unhooking the DRL. So the next thing they are using, um, or else we can end, bro. We can continue tomorrow.
Yeah,
What do you
sure,
think?
bro. Yeah, sure, bro. Because actually